Greetings and welcome, friends. Mr. Waddy here. I'm taking a look at the homework tonight. It's page 117, and we were talking about linear functions. So we're going to, as you might have guessed, linear line is there. We're talking about functions that are lines, but we'll get a little bit specific because they also have to be functions, linear functions. So it's got to pass the vertical line test. Let's see, question 5. It says, determine whether the graph represents a linear or nonlinear function. Explain. Does this look like a line to you? I mean, maybe in art class for your line art, but this is not a line mathematically. So this is non-linear. And one of the ways we could detect that is that it doesn't have a constant rate of change. Let's see. So this is going up like 0.2 and over 1, and then up 0.2 over 1. I'm already missed up 0.2 over 1. Like if I tried to like whatever that amount would have been, it's changing its steepness all the time. It's like slowing down, it's getting super steep, it's getting less steep. That's non-linear. Over here, check this out. Is this a linear function? Well, let's see. Let's pick one of these lattice points. Go to the other lattice point. I didn't have as many lattice points to pick here. But if I go down 1 over 1, down 1 over 1, down 1 over 1, down 1, it is just the rate of change is constant, right? We talked about that yesterday. It sounds like an oxymoron, a constant rate of change. How can something be constant and be changing? That's weird, but we're not talking about its value. We're talking about the value of how it's changing, right? This is getting more steep and less steep over time. This is constantly the same steepness. Okay, that's the way we would describe that. So this is a linear function. Also, this would pass the vertical line test. So, question: do you guys think this one passes the vertical line test? This one's actually a really interesting case. I believe it's a sideways. It's probably, I believe the rough equation for this is something of the sort of x equals y cubed. It might be like a -1 or something like that. But this actually does pass the vertical line test. You would think like maybe, well, what about right here? It looks like it would hit a bunch, but it actually like slows down, goes vertical just for a moment, like literally a moment, and then suddenly is no longer vertical. It actually does pass the vertical line test. So this is a non-linear, but it is still a function. Okay, and this passes the vertical line test as well. So it is a linear function. Let's see, let's take a look at this problem. Oh dear. There we go. Determine whether the table represents a linear or non-linear function. Explain. So let's see. First of all, if I'm going to determine if it has a constant rate of change, I have to make sure that my x's are consistent in their increments. Okay, like if I just picked 1 and then like 3 and then like 25 and then like 42, that's like a super irregular pattern for my x's, and I wouldn't be expecting a regular pattern for the y's. Okay, so whether you're counting by ones like we are in this case, or like some of the examples yesterday, I think we were counting by threes or something like that. As long as your x's, you have a consistent pattern we're plugging in, I'm looking for a consistent, constant rate of change pattern coming out for my output, the y. So let's see, what is the y changing by from 5 to 10? What does that change? Up 5, yeah, plus 5. And then 10 to 15, also up 5, yeah. And then 15 to 20, also up 5. So that looks constant. So we would describe this as a linear function. All right. It has a constant rate of change. Which I actually might describe that rate of change as being up 5 and over 1. As far as like my y over my x change, which sometimes they'll use delta. That's like a calculus symbol actually, that when they do that. The change in y over the change in x, or the difference in the y's over the difference in the x. Delta, tell you what, we're jumping into this. Delta is the Greek letter D, and so yeah, that's not a very good triangle. Here we go, a little better. Uh, and so you can think of D for the word difference. All right, so the change in y was up 5, the change in x was up 1, and from any point I was going up 5 and over 1, and up 5 and over 1, and up 5 and over 1. All right, so you don't have to worry about that too much just yet. Let's see, here's question 16. This one is tricky. Oh man, they done tricks us. Okay, it says the graph is a line, so the graph represents a linear function. Now, the teacher marked this question wrong, but doesn't that look that it's a line, right? What's wrong with it? What do you guys think? I don't know. Yeah, the x is constantly the same. This is what it fails in is the function part. It fails the vertical line test, right? If I drew a vertical line, watch how many times it hits this. Infinitely many times. It was like the most failure of the vertical line test possible. So it is not a function. It is a line. Also, we talked about linear functions yesterday as being of the form, or can be written in the form y equals mx plus b. And the issue is I actually can't write this in this form, okay? Also, if I asked you, what is the rate of change, okay? What if I asked you, what is the rate of change, okay? What is the delta y over the delta x? Watch this. Check this out. This is going to blow your mind. Ready? I'm going up infinity, right? Plus infinity. And what's my over? I'm going over 0. And that's just weird. Infinity divided by 0 is undefined. All right. This is what we actually will later refer to as no slope. Okay. It's just like super steep. It just goes up forever and never goes over, right? There's no horizontal movement there. So yeah, so that just doesn't work out. There is a way to write this equation, although as we already said, it's not a function. This is an equation of the form x equals -3, right? Someone said that x is always the same. If I thought of this as an input-output table, I would have had -3, -3, -3, -3, and then y would have just been like -1, 0, 1, 2, and this would have gone on forever. So that is a line, but it is not a linear function. There is a way to represent that as an equation, but it's a little bit bizarre. Let's see, I think that's the last one I'm doing. Do you have a question about that one? Okay, well, let me just say goodbye to our internet friends. Thanks for watching. Have a good day.